Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hello and welcome to Hardware to Save a Planet. I have Paul Hillman joining me today from the UK. Paul is the CTO of Entocycle, where he's on a mission to accelerate a global shift to sustainable protein using technology to raise insects in massive quantities. This is important partly because raising livestock for human consumption contributes something like 15% of global greenhouse gas emissions. And a big part of that is the supply chain emissions, including the production of the feed we're giving the animals. This is where Paul and Entocycle's insects come in as a more sustainable source of animal feed. Paul is a mechanical engineer with experience in the food and ag industries and also entertainment stage technologies. He started with Entocycle 5 years ago as a senior mechanical design engineer and has risen up to the CTO role. When I first met Paul and he told me about his tech, I thought it was so cool that I had to have him on the show. So Paul, thanks a lot for joining. It's an honor to have you.
Thanks, man. You're very welcome.
So your first job right before Entocycle was for a company called Tate Stage Technologies. I saw on your resume. I looked them up and it looks like they've designed some really crazy sets for some big name artists like U2 and Metallica. I'm just curious what that was like and how did you go from that to insect rearing?
That was absolute madness. Without question, it was kind of the easiest decision I've ever made to take a job beyond Entocycle was interviewing for that place and finding out what they do. So I think the company's called like Tate Towers now. It's like an American company originally, and Stage Technologies was like a British company that they took over. And so I worked more on the theatre side rather than the kind of the big performing acts and stuff. But I was technical lead and project manager for Cirque du Soleil's first theatre in China. So it was basically like 100-ton stage lifting a water show up between two moving audience decks full of people, and it had to move silently through them. And it was like engineering on a huge scale, like bigger bits of kit than I'd ever worked on, but in a theatre and with like acrobats flying above it and stuff like that. And it's probably the coolest and the most terrifying thing I've ever worked on. So it's just like, I can't spend the rest of my life designing stuff that gives me an anxiety attack like this. Like, if you go to, like, I'm a person, if I go to the circus or go to something, and if I see someone juggling, I feel like anxious about them dropping a ball. If I was the one who designed the stage that they're standing on, then all I just feel is anxiety. So at that point, I was just like, I can't do this for the rest of my life. I'll be too terrified.
Is it because the stage might fail in some way? And
well, absolutely, the stage won't fail. Like when we did the first testing of it, I stood under it to prove confidence that obviously it's the safest thing we've ever built. Like the safety factors on those things are enormous. Hence why like the machinery on it is so enormous. But there's still that thing, like if you know that a bit of kit that you designed and moving it, like every time I see something that I've designed moving, there's always that little nagging doubt, like in every, in everything we do, right? It's kind of just, you want everything you do to be perfect. And therefore it would ruin all entertainment for myself if I knew that what I could see I'd had a part in. So I really enjoyed it. But at the same time, like there's a part of me that always wanted to work in sustainability. And therefore, like much as that's really entertaining and it's really cool stuff and I really enjoyed it, it wasn't the mission that I wanted to go towards. And also, like, my dad kept telling everyone that I worked for the circus, and that was slightly alarming. So.
Hey, nothing wrong with that. My parents were in the circus.
Your parents were in the circus?
Okay, so now it's just insect lives at stake with your technology. Okay. How did you find Entocycle?
A job ad, like, it was as simple as that, really. I'd spent a year or two kind of vaguely looking at how does a mechanical engineer get into sustainability, and a lot of the jobs in sustainability looked like kind of big scale civil projects like windmills and stuff like that, and like there wasn't stuff for like someone like me who's a mechanical engineer who likes designing brand new things and kind of doing kind of cutting edge stuff. I didn't really see the stuff that like interested me. And before working in a startup, I kind of didn't have a startup mentality, so I didn't even know how you go looking at the kind of building stuff yourself, working from the ground up. I think like I started off working in big engineering companies, and that was how my mindset always was. And then, yeah, just saw a job advert, looked like the maddest thing that I'd ever seen and fundamentally interesting. And I think my opening line in my email to them was like, I want to help you save the world. And like immediately, like in the conversations I had with now managing director, then CTO, like we just hit it off immediately and definitely had a shared mission. And like for me, it's the sustainability is just a nice way of kind of feeling positive about myself as I'm doing my work, because actually I don't need more than that, because I really find the engineering interesting. Like the engineering we're doing here with the kind of black soldier fly larvae is fundamentally the most kind of interesting work that I've done, because apart from humans who kind of do what you ask them to do when it's stage shows and stuff like that, except for audiences who will always do the exact opposite of what you want them to do. The black soldier fly larvae, like they can do whatever they want. You kind of like you're engineering around them, you're engineering around their biology and their behavior and stuff. And it's very much we are kind of working to the biology, and that makes it fundamentally more interesting, because you've got to like you can't just rely on a firm understanding of gravity and kind of mathematical concepts. You've also got the kind of changing behavioral patterns of the larvae, which is really interesting.
I'm really excited to get into kind of the engineering challenges and everything. Before that, I was hoping you could help me understand kind of what the problem is that Entocycle's solving and why it's important. So I said in the beginning, it's about animal feed. I think your insects have become a feedstock for livestock. Is that true?
Yeah, sure.
Okay. Yeah. So the question is, what's going on with why is that feed supply so bad for the environment today, and why is this important?
I mean, it's like so the world is heading towards a protein crisis. Essentially, there's a protein crunch. We are not producing enough protein as a species to be able to feed ourselves once our population reaches a certain amount, and the protein we are producing is done in such a way as to be like totally unsustainable for the kind of the world population as it stands. If you look at where the majority of the proteins that we in the kind of West, Europe and North America get, huge amounts of those come from fish meal from South American waters. But nowadays they're actually doing krill meal as well, which is kind of one of the most depressing words I've ever heard. Krill meal, like fish meal where you take fish and turn them into meal. Krill meal where you go, there's not enough fish anymore, therefore we have to go further up the food chain and find other things because there aren't enough fish left anymore. And that is now like becoming a larger option. And then you've got kind of plant-based soys or plant-based proteins like soy, which again is just kind of linked to like massive deforestation around South America. Then you add to that your transport costs, both in terms of actual costs, but then really in terms of the climate costs, that you're devastating the oceans and the kind of rainforests, and then transporting all of that protein large distances to get to the markets that are looking for those specifically. And then with burgeoning populations in other countries, with climate change, where agriculture is going to get more difficult and become more variable as you go forwards and less predictable. We've already seen like large changes in the kind of wider kind of food network, where it makes it much more difficult for people to be like predict their agriculture and be able to kind of like get it to people where they need it. And there's also fertilizer. Like I think one of the things that was seen with the kind of the Ukraine invasion was the massive changes in oil like prices and availability, and the fact that out on fertilizer and availability of fertilizer, that's another area that's being massively impacted and will get more and more difficult as we go on. Black soldier flies or insect farming is a solution to elements of that problem. Like it's not the entire solution for the whole problem. It's a much, much larger problem than that. And it needs to be lots of different coordinated actions. And this is one of the facets of that solution, which is taking insects, which black soldier flies are the ones we use. There are others that get used, but for us, black soldier flies are kind of nature's perfect upcycler, basically. They are developed, they are by evolution, thousands of years of evolution have created this thing that takes the lowest quality food that you can possibly take and turns it into high quality proteins and feeds other animals higher up the food chain. We're not inventing anything when it comes to the animal itself. This is what it's designed for. If you look at, in nature, there flies laying eggs that get larvae, and they eat feces, they eat rotting food, they eat low quality foodstuffs, and then pigs, chickens, fish will all eat them. And then that's basically part of the solution for us. And we're relatively agnostic as to where they go. Like we're a technology provider. We want to be able to bring the technology to grow these things in the most efficient, optimized way possible anywhere in the world at the kind of cost points or technology points or like operator sophistication points that are in whichever area, and then be able to provide those solutions to the companies who are doing it. And that means that we can help anyone out. wherever and be like a much wider part of the solution. And then you're looking at kind of localized supply, I guess, is the key there, that you're looking at, you're taking a food waste, a local food waste, you're feeding it to your insects locally, and then you're providing it to your livestock locally as well. So if you look at Scotland, you take your whiskey distilleries or your breweries in Scotland, or like any food waste outlets, supermarkets, lots of other areas where you can get it. And then you keep your insects locally in Scotland as well. And then you have huge amounts of salmon farms, and therefore you've now like localized your entire food supply for them. And there's like really good data showing that young salmonids, when they're eating black soldier fly larvae, they will do better than on pretty much any diet you can commercially buy right now. And that comes from the fact that salmon, when they're young, travel upstream. Like, this is what they're supposed to be eating. They're not supposed to be eating sea fish or krill while they're a young salmon. They should be eating these things. And for us, and things like chickens as well, and like pets as well, we've done like a lot of the kind of early markets that you see like soldier fly companies going into is all pet food markets. And the point of that is like, this is what small animals eat. Like, this is what cats eat. This is what chickens eat. They're like eating insects and things like that. And therefore, if you look at chickens as well, but like the antibiotic requirements for a chicken that's eating insects is significantly lower than the antibiotic requirements for a chicken that's not eating insects. And that's because it's good for their gut health. It's what they're supposed to be eating. It's not just a plant-based diet, it's part of what they're supposed to be eating. And therefore you end up with a kind of general improvement in those animals. And again, like, reduction of antibiotics in animals is a massively important thing for us if we don't want to become exterminated as a species.
And these are, I mean, I wasn't familiar with black soldier flies before I met you. It's just a naturally occurring fly. Like, will I see them around? Are they in the US or, yeah?
They are, depending on what latitude you're on. So they are a tropical species. Like, I know Europe as a reference point, and kind of like southern Spain, southern Europe is kind of as far north as they get. They like warmer temperatures, 26, 28 kind of year round. Anything colder than that, and they don't live for a huge amount of time. So they're a tropical species. They're endemic pretty much world over. So our founder, Kieran, who began the whole company, he encountered them first working in Brazil and kind of worked on a black soldier fly farm in Brazil, and then brought the idea back and kind of got inspired with the idea of automation and creating it as a much like wider, more automated system, a much, much larger scale. So yeah, if you travel down to the southern states, I think you probably would see.
And then you can grow them. They like that latitude, but you can grow them anywhere if you're controlling the environment, I guess.
Absolutely that. So it's similar to vertical farming. We're controlling the environment, and that's like to ensure consistency. So if you're in a tropical country, and again, we've worked with companies in tropical countries in North Africa, you can grow them without any sort of climate control. But the problem is, the kind of, once you get to certain scales, what you're looking for is consistency of supply. You need to be able to take in a certain amount of food waste and then process that and then send that out as a product at the end of the day. And therefore, if you're leaving it up to the like wider ambient conditions, then you're going to end up with like a variable egg supply or something like that. And then as soon as that starts varying, then it becomes much harder to predict the rest of the process.
And what is it exactly about black soldier flies that make them so well suited, like compared to a housefly or some other insect? Why are they the right choice?
I think that there's kind of the two or three main points that make them essentially the perfect insect for what we're trying to do. And so one is essentially voraciousness of appetite. These guys, when they're an adult fly, they don't eat. They don't have developed mouth parts. All they can do is drink water, realistically. They have to do all of their eating when they're in their larval form. So they grow like 5,000% in 8 days or some ridiculous statistic like that. I love showing people the development time between like day 5 and day 8, because it's unbelievable how fast they grow. And that's because they're putting on all of their mass while they're in larval form, which has to be enough energy to get them through, like they're turning chrysalis form and then emerging as a fly and then go and mate as a fly and then lay eggs again. So they're trying to pack all of this energy into this really short period of time while they're a larva. So that rate of growth is phenomenal. The amount of eggs they lay, so the female flies can lay up to 1,000 eggs. If you compare that to a cow, will have 2 or 3 calves, or 1 or 2 calves, realistically. Like, I mean, the difference is astonishing if you're trying to like produce livestock on a grand scale. Because they don't eat as adults, it means they're not a disease vector. So then they can't pass disease because they're not going from a food source to another food source as a fly. And if you compare them, so like a housefly eats, right? And it goes from like, it goes and eats something, and then it goes and eats something else. And the way that it digests in that is to like excrete, stomach acids onto the food that it's eating and stuff. So kind of leaving a trail of destruction wherever it goes. Whereas these guys don't eat. So therefore they're not a vector of disease. They're like viewed as, they're effectively completely harmless as a fly. And they live only for a few days as a fly. They kind of, the point is that they mate once and then they die. So therefore they're the ideal in both like from a production perspective, from a safety and regulation perspective. And that's why the regulations of them has been like really well handled and really well understood, because they are deemed to be such a kind of safe and understandable insect. And then, yeah, basically the other key point is feed conversion ratio. So attached to the kind of voraciousness of them, as I said, like essentially what you want is an insect that turns the most amount of food coming in into the most amount of insect going out with the highest quality protein content within that. And these guys are amazing at that. So you put in 3 to 4 tons of food, you're getting out 1 ton of insects, and that's massive difference compared to pretty much all other livestock. If you think other animals, like they kind of have to worry about having legs and eyes and walking around and mating and stuff like that. Well, these guys in larval form, they're just a mouth that moves around eating. That's pretty much all they do.
Okay, so it's like a 3 or 4 to 1 feed to
4 to 1 is like yeah. And again, it's massively dependent on what you're feeding them, right?
So what is the main feed source for them?
So I mean, that massively varies. Like that's the joy of it, is that there is no, you almost don't want to put them on a mono diet, right? You want to have this wide recipe. And if you think about the kind of like the food waste that you get in pretty much any country, it's not going to be that consistent. Like you'll get, all right, from your kind of like flour mills and stuff, you'll have this kind of constant output, but that's quite a useful output that can be shared amongst other livestock. What we're looking for is the kind of supermarket waste, the stuff that is just going to rot, is going to go to landfill, or is going to go to anaerobic digestion. And like anaerobic digestion is awesome. So you send this stuff off and you turn it into electricity. But actually, we can be a step before that and then still send the outputs that we create to anaerobic digestion. So you can valorize pretty much any food waste and then turn it into high quality protein. And then the byproducts we produce, you can then still send that off to anaerobic digesters and they can turn that into electricity. So there is no specific feedstock that is like perfect, because there's such like a wide range of things they can eat. But again, I think it's just like, I think it's key to talk about the separation of those different chains. So like, when we're looking at sanitation solutions, then the insects wouldn't be going back into the food chain. You'd be taking like animal slurry, and then the outputs from those insects would be going to create bio-oils, bioplastics. Like if you allow them to age to a certain point, then they have really high percentages of chitin, and chitin has like lots of potential uses in pharmaceuticals and cosmetics and those things. So there's lots of different outputs for that, but it just depends what your inputs are and where you want to put them.
So the ones that are going back into the human food chain are going to be fed by, it sounds like, food waste from supermarkets, that kind of thing, a pre-consumer.
Pre-consumer food waste. Yeah, that's the kind of regulatory requirements that we have here. And that changes from country to country. And I think we follow the regulations first, but also I think we have to be sensible about if a country doesn't have the same regulations as another, we need to use our expertise with the insects to know what are good foodstuffs. And those regulations exist for a reason.
Okay, cool. And yeah, that's a huge part of the whole food waste problem, is that pre-consumer category.
Yeah, it's enormous, right? It's huge.
Yeah. I'd love to just kind of walk through like the life cycle of one of these in your system, so I kind of understand the steps along the way. And I don't know where the right place to start it is, like maybe with an adult fly that's laying eggs, kind of I don't know if you call it eggs, but with the adult fly, what happens from there?
So begin with the adult fly. So the adult fly lives 5 to 7 days, say, at most. They will find, male and a female will find each other, and then they will mate once, and then the female will go to lay eggs. The kind of the criteria for her laying eggs is that she'll find, so like essentially she's looking for a food source to lay the eggs above. So it's really interesting. They do not lay their eggs directly on the food. They will lay their eggs in the wild in crevices above the food. So we mimic that by creating artificial odors using fermented foodstuffs and a couple of other secret recipe elements to encourage the female flies to lay eggs in what we call egg traps, specific areas where we want them to lay. And with that, we're kind of mimicking the kind of natural crevices that they'll lay. And we did like 9-month-long knockout competition to find out what the preferred material and geometry for a female fly to lay their eggs was. It was lengthy and really interesting to see the kind of different approach in terms of, because what we're trying to do is get the most amount of eggs in a specific area from a number of flies, right? So they lay their eggs, and then the eggs will hatch after like 3 or 4 days, 2 to 3 days. The eggs hatch, the larvae or neonates, as we call them in that stage, will crawl down, and they will naturally drop to the food source below. Then they'll grow out in that food source essentially. And the kind of life cycle of the larvae is about 30 to 35 days in a larval form, turning into a pupal form. If you're looking at the production cycle, so you will take those kind of larvae at a much earlier stage, and that will be your production stock. So after 12 to 15 days, that's when you would be harvesting them for production purposes. And that's because at that point, what they'll do is they'll kind of get a certain protein profile as a larvae. And then because they then want to store that energy, they'll start to change from protein to fat. So they're storing the energy that they've built up. So we want to take them when they're kind of at peak protein, but it does mean you can choose the recipe that you want, right? So if actually you want more fat because you're trying to do some sort of oil extraction, then you can take them at a later time. But just on the breeding cycle, so the larvae eats and eats and eats. Interesting, like the way they operate together. And one of the things that makes them ideal for farming is so the female can lay up to like 1,000 eggs. So you've got these like big colonies of black soldier fly larvae. And the first digestive step is them moving relative to each other. So you'll get these kinds of swarms of larvae moving together relative to each other, and their interaction of their bodies and the food is essentially the teeth. It's the first digestive step to break up the food before they start eating it, which is why when you put them, you have to intensively farm them. Like if you put too low a density of larvae in a crate or in whatever system you're using, they're not going to be able to digest their food quickly enough. So therefore you pack them in to the point that they want. And if you overpack them, they leave. That's my favorite thing about them, is that they are the kind of probably the only animal in the world that wants to be intensively farmed. But if you get it wrong, you cannot keep them in. It's not possible. They can crawl up vertical walls. They can fit through any surface. So if you don't create the perfect environment for them to live in, they just walk away, which makes them really interesting as an engineering challenge, that you have to like maintain the climate just the way the larvae want it. And to be fair, they're pretty relaxed about the climate that they have as long as you keep the food in there, but it makes it an interesting thing for us to have to do. So yeah, so your larvae grow up, they turn into a prepupae and then a pupae, and that's then essentially forming a hardened shell on the outside, and they'll shed their skin multiple times, and then they'll kind of sit in that for like 10 to 15 days ish, I think, maybe a bit less, and then they'll emerge as flies, and then the whole cycle starts again.
And you're harvesting them before that pupae stage, mostly?
We have like a breeding cycle, so we need a certain percentage of the population, 2 to 5% of the population need to be the breeding cycle. So we'll take them to flies to eggs, and that basically creates the whole livestock. And then we'll divert off the vast majority of the insects will become the kind of the livestock essentially, and they're the ones that will get processed and turned into protein meal or dried larvae or frozen larvae, depending on what industry you're sending it to or what your end product is.
Fascinating. Okay. Why is technology important in that process, or how do you use technology to improve it? I mean, at some level, it's a very natural thing. It sounds like you could just kind of put some feces out for them to eat it or whatever, but how does technology help?
So I think the technology is really useful to create consistency, basically, of supply in and supply out. Like if we want to be part of the food chain, then we have to be like a reliable, consistent partner within that, right? You have to have a specific amount of food comes into your facility per day, gets fed to your insects, and a specific amount of insects come out per day in order for you to be like kind of a reliable part of it. And part of what I said earlier was that what we're trying to do, like if we're replacing elements of agriculture that is being damaged by climate change, then actually they're the ones that's going to be a struggle if you're trying to, like, consistency is difficult with massive changes to climate, whereas we are looking at a vertical farming methodology, which means that we can be consistent in our output. And also because the black soldier fly has such a wide and varied diet, we can be really agnostic about the foodstuffs that are coming in, that you can take food waste from pretty much anywhere, like supermarkets, like industrial processes, like all of these possible options. You can create the recipes and the insects will still thrive on those different food chains or foodstuffs as long as you understand how to treat them right. To get that consistency, to get that like output level, that's where we're applying the technology. And again, you've got to kind of think about, this is the very beginning of the industry. This industry has only been around for like 10 to 15 years. If you look at the size of a chicken in 1920 compared to a chicken in 2020, like they don't look like the same animal anymore. It's like astonishing the difference in the size of those two things. We're very much at the 1920s end of what we're doing with the black soldier fly, with the kind of the selective breeding, the kind of genetics programs to create much more efficient, much larger larvae that can thrive on an even wider variety of diets that can create a different set of outputs out the other side. So like technology needs to be used to run the process, but technology will also be used to optimize the larvae themselves and like continue and improve the process as we go on. And I think for Entocycle, like our key things are, so we focused on the storage and climate for the insects. So ensuring that they are living in stable conditions that are like ideal for them to go through. the feed recipes, understanding that, the kind of how you put these different things together and make sure that the insects are going to do the best they possibly can on a given availability of resources. But then we spent a lot of time looking at the kind of ensuring consistency of the larvae themselves. So one of the keys to it is making sure that you have the right amount of larvae at the beginning of the cycle. So when they're born, the neonates that I talked about, they're like 0.3 millimeters long. They're tiny little things. And they will, like, as I said, they hatch from the eggs and they drop down into a foodstuff. If you do not know how many neonates you have in a specific crate at the very beginning, then it's really hard to be sure of the rest of your process. Like if you've got the wrong amount of neonates, if you've got too many or too few, how do you know how much food to give them, how much heat to give them? Like optimizing that process is difficult. The current methodology is you wait till they're big enough to count by hand, and then you can count them by hand to a certain extent, and then you kind of weigh the rest on a kind of mass tapering method.
So you're counting the larvae, or
correct, yeah.
Yeah, when they're at that stage. Okay.
But what you have to do then, so you've let them grow out in food for a few days, then they're big enough to see, then you separate them from their food, and then you count them, like enough of them by hand.
Manually.
Yeah. And then you can kind of you weigh like a small sample, and then you can kind of guess how much the big sample, like how many are in the big sample that you weigh, right? That is manually intensive. It is inaccurate. And I think one of the interesting things is because you're separating them from food, you tend to separate them from the food by like sieving them out. And then because the larvae are photophobic, they'll try to escape from the light. So you can, like, if you put the food across a kind of across a sieve, the larvae will naturally drop down. But then what you're biasing for small larvae rather than large larvae. So you're actually deliberately, like, you're selecting the wrong larvae if what you're trying to do is improve your population in terms of size and growth. So what we've created is a system called the Entocycle Neo, which basically takes the eggs, and when the larvae hatch, instead of dropping them straight directly into a foodstuff, we're channeling them past high-speed line scan camera, where we are then accurately imaging the larvae, and then we can count them accurately, and then batch them into specific crates. So you know exactly how many larvae are in every single crate. And then once you know exactly how many larvae are in there, you know exactly how much food to give them, how much water to give them, what the air conditions need to be for those larvae, and then you can get a really optimized batch every single time. And that's the kind of key to your consistency there. And then we kind of apply that in different areas as well. So we've got like technology where we're able to accurately count the number of flies in a cage. And that's massively important when you're breeding flies. To know how many there are is actually like the biggest variable that you have on the amount of eggs they're going to produce is the amount of flies within a cage. Because if the population density is too high, it will actually cause them to mate less often because of the number of interactions. If the population is too low, then you're essentially just wasting space because you've got not enough flies in a given space. And at that point, for an industrial process that we're trying to produce, you've got to use all of your space as efficiently as possible. So we've produced a system where, using machine learning algorithms, which can actually detect what is a fly and what is not a fly, we can tell you how many flies you have in a room. And we can also tell you what the fly behavior is like and how healthy those flies are. And so by kind of applying that kind of technology, we're just bookending certain points in the process and then ensuring that we know exactly what's going on at those points in the process, which means the whole process is smoothed out and we can optimize each of those areas.
How do you count flies in a room? I mean, I can understand with computer vision identifying flies, but they're flying around, right? Is this a challenge?
It is a challenge. It's a really interesting challenge as well. So you can look at surfaces, first of all, depending on how you want to do it. You can take a certain amount of cameras and you can look at all of the surfaces in a room. So we have these white-walled rooms, and then you can count flies on the surfaces. You can also set the focal depth of cameras across a certain distance of space,
cool.
which then will allow you to see what is in focus and what is not. And that will then allow you to count flies on the wing as well. So with a certain amount of cameras, you can exhaustively count every single fly in the room. What we then did is take all of the data from the multiple cameras, imaging every single thing in the room, and then you can go, all right, and what if we use this number of cameras, not all of them? How accurate can we then predict the amount of flies that there are in the room, only using 2 cameras, say? So you don't have to install so many cameras every single one that you produce. And that will allow you to essentially sample count accurately how many flies that you have in the room. And so you're kind of then predicting based on 2 cameras what your original 10 cameras saw within the room. And that we've seen with really, really good results so far.
And that's just driven by cost, trying to keep the cost of your systems down.
Absolutely. Like, we are competing with, like, we have to be sensible about the protein that we're producing. Like, no one will change to this protein if it doesn't compete on cost with fish meal and soy. The reason that is still used widely is because it is the cheapest things you can buy. So For now, if we're looking at like what the reason the market moves first into pet feed is because there's more of a premium on that, because people want to feed their pets on a sustainable diet. So we've seen massive increases in the insect-based pet foods because like insects are so much more sustainable than all other animals, and people don't want a lot of people don't want their animals to be vegetarian, and therefore you can see that that's a massive potential. Whereas if you're looking at feed for animals, the cost is essentially the biggest parameter every single time on that. Like it's just much less sensitive to.
That's going to be the last market to adopt, or the most cost competitive market.
Well, again, I suppose it depends on the people doing it, right? Like I guess if they're the ones who are forward thinking and understanding that consumers do care, and that if they are then marketing their products in a way that they're saying this is what our food chain is, then they can then command a cost premium again, and then it becomes easier. But at the same time, for us, we want to be cost competitive with those forms of protein, because then we can change to a much more localized supply and reduce climate change, which is what the company was founded for.
Yeah, I was going to ask about that earlier, actually. Like, if you just think about kind of like the beef industry must be feeling a lot of pressure from Impossible Meats and Beyond Meats and these kind of alternative proteins, and just consumers' demand to reduce their footprint and everything. So it seems like do you see that as a driver for these things and potentially commanding a price premium for something like this?
Yeah, massively so. Like I think that is consumer behavior is one of the things that's it's the main factor driving all of these things, and people realizing that. And I think obviously people in industry as well. Like if you speak to farmers, they're going to be the first people who suffer from climate change to a certain extent. They understand what's coming. You speak to the kind of aquaculture farmers and producers, they're much more aware of this than the majority of us are, because they're the ones who are right on the edge and have to understand these things. So you speak to anyone in industry, they'll have a much better understanding of the problem than most consumers, but it's just harder for them to change attitudes because they're like part of these larger institutions. But they're certainly willing to do it, and that's part of what we have to do. We have to give them choices that are easy for them to make, right? And so if we can make something closer, more cost comparative, then it becomes much easier for them to push in the right direction and improve the kind of food chains to them.
I do want to just call out, you mentioned your kind of egg counting system. And I have to say, when you first told me about that, I was kind of picturing these little eggs dropping every few seconds, and you've got a camera counting them. But if you go to the website, and I would suggest everybody who's listening to go to your website, there's a video of this, and it's like raining. It's like a rainstorm of eggs going past this camera. It's pretty impressive to see both that you're counting all of those and just to kind of visualize the quantity that we're talking about. It's pretty.
Yeah, I mean, so normally that one's doing we kind of set the standard for about 3,000 larvae per second is what goes past it. We've exceeded that, and it's just a question of balancing accuracy versus throughput. I spent the first 8 years of my career working for a company called Buehler's Sortex, which is an optical sorting company. So that's basically like any small granular food that you want to grade the quality of it. You put it through past cameras, and then you remove anything that is not what you want it to be out of the system. And so basically that's kind of what I kind of as an engineer grew up working on. And so it's kind of a development of that technology further with the counting and the batching underneath.
And then the other part of your background, from like we talked about the stage technologies, is a lot of industrial automation, big mechanisms and motorized systems and stuff. Have you flexed that side of your expertise at all in this at Entocycle? Is there any kind of automation or mechanical manipulation happening anywhere?
Yeah, massively. It's so we look at it as almost a warehousing challenge to a certain extent. So we've got these specific automated processes that we're looking at. And then within that, there's a whole bunch of movement of crates, of pallets, of we're bringing in, say, 100 to 200 tons of food per day. And then we need to store that for a certain amount of time while the larvae can eat it. And then we need to take them away, separate them, and process it. And that involves large movements of crates filled with larvae and food. In terms of robotics, AGVs, autonomous guided vehicles, so you're moving those things around, just automated door systems. We want to make sure that we can offer whatever solution the customer wants in terms of complexity, really, or automation level. So we want to be able to help the kind of don't have a huge amount of money available right now, but I do have low labor costs. So we can offer those solutions where you can just have a guy with a pallet truck moving stuff around, or you can go for the fully automated systems where you've got these AGVs, autonomous guided vehicles, so just little robots that basically roam around the floor, depositing pallets of crates wherever you want them.
Yeah, I'm picturing the Amazon warehouse. They've kind of made that famous, the robotics that move boxes around and stuff.
One of the first trips we did was to an Amazon warehouse just to go, is what we're facing a warehousing problem? And so much of it is. So yeah, absolutely. That's definitely an inspiration that if you can, that all you're really doing is storing them in a good climate condition for them for a certain amount of time, then yeah, absolutely take inspiration from those companies and use the methodologies that they've got and leverage their supply chains, which is what we've done across the board. And it really, like, theatre automation it's really specific, but at the same time, actually, like, it's just movement of large bits of steel for the most part, and therefore it applies to like a large amount of other engineering projects. I was kind of surprised at how much of the magic behind there is actually just a winch moving a rope. That was a weird thing to find out.
Yeah. And where are you in the development of your systems? Do you have systems in commercial operation now? Are you doing more? It sounds like you're at least doing some pilots. What does that look like?
So we developed and ran a pilot facility 3 years ago, and then we've been developing large-scale industrial facilities. And so we've got large-scale modules that we're running in London, and you can see our facilities and the way that we're running the insects there. And then we've got commercial partners that we've worked with to install equipment and to work with to put full-scale facilities in. And then we're kind of working with partners right now to be able to put our first major facility in next year. So yeah, it's we've got the technology proven out at large scale at commercial sites, but it's our first full factory that's going to be the big achievement that we're aiming for next year.
Okay. And I saw one thing that stood out to me. I saw on your website mention of this partnership with University of Leeds, using pig manure as a feedstock for your soldier flies, and then the larva is then a feed for the pigs. And I just think that you mentioned it earlier a bit, but just that the potential for that circularity is really cool.
It's really interesting. And I think from our perspective, like as a university, and they're wanting to find out really new, they want a partner who understands the insects really well, and they want someone who can provide them the kind of R&D facility they require. So we designed this bespoke R&D facility that gives them control on their climate and their kind of production processes, and allows them to do the trials that they want to do, which is all different kinds of slurry. Because one of the biggest problems, like we've seen it a lot in the UK, essentially, is that kind of the use of slurry as a waste output is now extremely limited. It used to get put on the fields, but you can't do that anymore because of the kind of damage it does to the wider environment. So if you can feed those to insects, the output you get is insects that you can use for energy if they're not going into the food chain. But you also get frass, which is the kind of byproduct, larval excrement essentially, but is a fantastic soil conditioner and can be spread onto the fields. And we've seen so we're part of a large scale UK grant, £10 million grant with a lot of other insect providers and universities within the UK to basically accelerate the insect industry in the UK. And a lot of that is focused on the uses of frass, because we've seen quite astonishing results on a variety of different plants. If you get the concentrations of frass right, you can get these exceptional results. And it's interesting for us, that was never a factor within the kind of business models we were developing for our partners. That was it's an output, but it's not it's one that might be valorized at some point in the future, but not something we looked at. And now with this research, we're looking at that could just be for these slurry, for the processing of slurry, that could be the output. You essentially bring in stuff that's not safe for the environment, and you actually produce something that's significantly better.
Awesome. So you said earlier that this industry is kind of at its very early stages, comparing it to chickens in the 20s. I'm curious what you see as kind of your vision for Entocycle or the industry, but really Entocycle in the next, 5 to 10 years. Where do you see this company going?
It's a really good question. I think for us, we will continue to develop really interesting technologies. So those will be around the kind of optimization of the process. Those will be around being able to take in the widest possible range of foodstuffs. I think that's really important to us, is to be able to, as part of our investment that we've got from our excellent investors, is we are tied to climate goals as well. Our investors are interested in profit, obviously, but actually we are also tied to providing, we have to reduce or remove a certain amount of carbon from the atmosphere in order to achieve our goals with them, which really focuses the mind when you know that that's part of what the company is being judged on entirely.
So I was just going to ask, who are your investors?
Clementum is the main investor, the lead investor. Yeah, a really interesting,
awesome
climate fund. And yeah, they've ensured the way that our business model is we are judged on dollars made and tons of carbon removed. And that's, a really interesting way for us a really good way of ensuring that we do what we said we would do in the kind of founding of the company. And so we've got from the technology side, we're going to keep developing that technology to kind of optimize the insect, to do the selective breeding necessarily to kind of create genetic programs that are automated within our systems there's a whole host of really interesting R&D projects out there that we have to be very careful what we pick and choose, so we get to stay focused and do the right things that our customers need, rather than all the cool fun stuff as well that like it's really, really interesting to try and to look at. And then I think the industry is likely to grow very quickly, and we're hoping to be in a position where, because we're not owning and operating our own facilities, we are able to work with lots of different companies. We're looking at different waste suppliers to be able to build facilities all over the world, essentially. And I think part of our mission is localization. So being able to go to the markets where it's required and be able to produce the insects directly in those markets. And also like different levels of technology and different levels of approach. What we want to be able to do is not just service the markets in Western Europe and the US, but to make sure that kind of in the biggest emerging markets where this is just as important, in those places we're able to give them what they require, regardless of what labor costs are or kind of automation requirements.
Very cool. I have a few last questions that I ask everybody.
Cool.
How optimistic or pessimistic are you about the future of our planet, and why?
Like that really vacillates depending on the day or the last conversation I had. I think my sister-in-law, I'm going to like misquote her entirely, but she is someone who was very pessimistic. But she read a quote or heard a talk where you can't start swimming while the water is around your ankles. You can only start swimming when the water is around your waist. And I'm probably getting that wrong, but essentially, like, the biggest anxiety I've had about climate change is the kind of the lack of action, that you look around and you see it and you're like, why isn't anyone doing anything? Like, we all doomed. Why isn't anyone doing anything? And then I think partly that I'm working sustainability, so I meet a lot more people who are also like working in sustainability who are kind of doing something. But also I think there is just a much wider drive now for people to try and have an impact either through consumer behavior or like direct action that they're taking. So I think I'm generally optimistic, as optimistic as it is possible to be while still reading newspapers and understanding what's going on fairly widely.
Yeah, I like that. Who's one other person or company doing something to address climate change today that's inspiring you?
So, like, there's big companies and there's like probably a few larger examples that I can give, but actually it's a company called Charge Fairy, which is quite a small startup in the UK who does a really interesting model where it's basically like on-street charging for electric cars, which for someone like me or for loads of people who live in cities, there's nowhere. Like, one of the biggest barriers to entry for electric cars is being able to charge it, right? If you don't have a driveway, and like if you live in London, you don't have a driveway generally. And they offer a service where they basically will charge your car at night without, like, on a phone app, and all you have to do is sign up for the app and they will come around and charge your car for you. And that is, like, I know the founder, and it's just the kind of small concept. It's like, oh, that's incredibly obvious. Why wasn't that being done? And there's so many of those smaller niche ideas that when you talk to the people doing it, when you understand where that's coming from, like, those are the small increments that are going to build together to create the entire change that allows us to have like a fully electrified economy for everyone.
That's awesome. I have not heard of them, but yeah, anything to help adoption. And it's Charge, I'm just looking them up. It's Charge Fairy as in Tinkerbell. At first I thought it was very cool. What advice do you have for someone who isn't working in climate today, but wants to do something to help?
Well, so I mean, like, consumer choices are really important, although not all of us get to make those consumer choices based on the kind of like cost of living crisis that a lot of people are facing right now. I think if you want to get involved in it, like, there are networks where you can find other people who are interested in it. Like, I've been to a few kind of climate networking panels and networking conferences in London, and I know they're certainly countrywide in the UK, and I'm sure worldwide. And that's where you get to meet other people who are really interested in doing these things. And that's kind of where these startups get formed a lot of the time. You get a bunch of people who are like interested and interesting and wanting to have these conversations and want to do something. And if you get two or three of them in a room together with a couple of beers, then quite often you'll come up with some interesting new ideas. And so, like, I was really lucky to find a job advert for the job that turned out to be the one that turned out to be my dream job, essentially. But I think for most people won't get that lucky. So therefore, like, the more you can kind of push into those networks and make those connections and meet those people, then that's the best way of getting into
it. Yeah, I have found that myself too. Awesome. Well, Paul, that was super fun and incredibly interesting. I'm really happy to have met you and to know that you're out doing this work. Thanks so much for your time.
Thank you, Dan. That was really interesting. Thanks, man.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, and Google Podcasts, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.